Today we're talking about applications and models of our trigonometric functions. So golden oldie, you guys have seen this before. You saw it in geometry, you saw it in algebra 2. We want to make sure that you know what we're talking about when we ask you to solve a right triangle. So in this case, we've got a right triangle ABC, with C being the right angle. And they told us that A is 40 degrees, and that B, side B, is 27. Side B is always opposite angle B, and its measure is 27. And they ask us to solve this triangle. What are they asking for when they ask you to solve a triangle? Yep, all the missing parts. We're looking for side A, we're looking for side C, and then we're also looking for the measure of angle B. And you and I know this is a 90-degree angle, so you don't have to write down that angle C is 90 degrees. Okay, so where do we want to start? Angle B. Let's take the easy fruit, right? So 90 plus 40 is 130, and 180 minus 130 is 50 degrees. Or it's a right triangle that leaves 90 degrees to share between the two acute angles, and 50 degrees. So now we want to find A or C next. You choose. Okay. So if we're finding A, opposite and adjacent, right? Again. So tangent of 40 is A over 27. We did. We just didn't ask you to solve the whole triangle. We gave you one thing. Absolutely. Yes, we did things just like this last year. So this is just a quick review of how to do these. So now, how do we solve for A? Multiply by 27. A is being divided by 27. So always solve it first before you break out the calculator. And then what's the next thing you have to be worried about? Radians or degrees. Okay, this is a degree, right? So make sure your calculator's in degree mode. And you're going to take the tangent of 40 and then take that times 27. And what's the tangent of 40 times 27? All right, 2 decimal places, 22.66. Did everybody get that? Does that seem like a reasonable side A? Absolutely. Okay. Actually, my triangle's probably not drawn properly. This looks like it should be the 50-degree angle, and that should be the 40, but it's a reasonable answer. Okay. Now we need to find side C. So whenever I do these, I try not to use the 50 degrees or the 22.66 that I just found. I try to use the ones that I've been given. So I was given 40 degrees adjacent, and I'm trying to find the hypotenuse, so cosine. Cosine of 40 degrees will be equal to the adjacent over the hypotenuse. Absolutely. If you wanted to, could you use the Pythagorean theorem? You certainly could. Okay. It could be off a little bit because we only rounded to 2 decimal places. So, and that's probably more work than it is to use the cosine. So, but yes, absolutely. Okay. Now, let's solve this guy, though, before we plug anything into the calculator. We're going to divide, what? The 27 by the cosine of 40. Because when we cross multiply, the c is coming up here, right? We multiply both sides by c, and then we have to divide the 27 by the cosine of 40. And we get to 2 decimal places. Okay? Easy peasy, right? No problems with these? Okay. Remembering SOHCAHTOA. The next one is more of an application. Okay? So we're going to get lovely word problems, but they're not hard. Okay? We just have to draw the picture. So the height of a kite, if all 50 feet of the string is out, is what we're trying to find. So we have a boy who went out flying kites. He was holding the kite 3 feet above the ground. and all 50 feet of this string is out, and the angle of elevation is 34 degrees. So this was my son a couple years ago, and we were out flying a kite, and he said, Mom, could we figure out how high that kite is? I said, well, yeah, as long as we ignore the string sag, because there's always a sag because of the string, we know that the string is 50 feet long, and you have it all the way out. We'll take a picture, and then we'll go measure the angle and see what kind of angle it is, and we can use something called trigonometry. And so this angle was 34 degrees, and we want to know the height of the kite. And that was supposed to be a 90-degree angle exactly. I tried to superimpose that. And he was 3 feet from where he was holding it above the ground. Yep, we'll have to have h plus 3 when it's all said and done. Okay, so what part are we missing? Yeah, the angle is 34, right? It was given, and the height is what we're looking for, right? That's the opposite, and we're using the sign, the hypotenuse. Okay, so sine of 34 is h over 50. And again, our calculator's already in degree mode, right? So we just simply take 50 times the sine of 34, and what do we get? $27.96. 28 feet, close enough. We're not that precise, right? So we're at 28 feet, and then we have to add the height of the boy. His name is Anthony, not that it matters. Extraneous information that we throw at you. Okay? So we can handle those kinds of problems, right? Especially when there's a picture given. All right, same idea. Now we have a ladder. And the ladder's 13 feet long. And it's leaning against a house. The house had better be perpendicular to the ground. Even in San Francisco, they build them that way, right? Okay. And the ladder is 13 feet tall. We want to know how high up the side of the house are we, and the elevation for the angle of elevation for the ladder was 69 degrees. When we're talking elevation, we're always talking about from the base up. What is that angle? Okay. So we're trying to find h. What are we going to do? Sine again, isn't it? Sine of 69 is h over 13. So take 13 times the sine of 69. What do we get? 14.14. Okay. So just a little over 12 feet in the air. At a reasonable estimate in a two-story house? Absolutely. Okay. Need a bigger ladder to be able to reach the tops of those windows. All right. So here's where they don't give you a picture. Okay. A point 20 feet in front of a house. From that point, there are two angles. The angle of elevation to the base of the chimney and the top of the chimney are 37 and 45 degrees respectively. Find the height of the chimney. So sketch a picture. at a house, right? And a point 20 feet in front of the house, angle of elevation to the base of the chimney and the top of the chimney are 37 and 35 degrees. So we've got an angle of elevation from the base of the chimney, 20 feet away, is 37 degrees. And an angle of elevation to the top of the chimney from that point 20 feet away is 45 degrees. How are we going to find the height of the chimney? We could use a 20 and 45 to find the height to the top of the house, right? Okay, so that would be adjacent and tangent. So we would use the tangent of 45. Hey, what is that, by the way? 1. That would be h over 20. So what is the height of the chimney all the way to the top? 20. Okay, now what? Tangent of 37 equals our little h, or our, I don't know, b, call it b instead, b over 20, right? And so we'll take 20 times the tangent of 37. What do we get? 15. 15 equals b. So if the whole height is 20 and the height from the bottom to the ground, bottom of the chimney to the ground is 15, how tall is the chimney? Easy enough, right? Drawing the picture. That's the kind of question you'll see on the ACT. And they'll have things like 20 and 15 and 5 and so on. Questions on this one? Okay. From the time a small airplane is 240 feet high and 5,200 ground feet from its landing runway, plane descends in a straight line to the runway. Determine the plane's angle of descent. Again, the ACT loves story problems. Draw your picture. I'm going to draw this to scale, and I'm certainly not doing it, I'm sure. We have 240 and 5,200 ground feet. There's our airplane. Okay. Terrible airplane, right? So what are we going to do? We're going to find the angle of descent. What does that mean? Yeah, the small angle, okay? It's going to be the same as this angle. Basically, if we looked at its horizontal, right, we're looking for this little angle here. And because two parallel lines cut by a transversal, right, the alternate interior angles are equal, it's also going to be equivalent to that little angle down there. Does that make sense to everyone? That's why we teach you geometry. All right, so we could find this beta if we wanted to, or we could find this theta if we want to. Which one do you want to find? This one, the theta? Okay, so theta, we're looking at opposite and adjacent. So the tangent of theta, 240, 5,200. Divide that. Get a really tiny decimal, right? What are we going to do with that number? Not the cotangent, but the inverse tangent, right? The arctangent, okay? We want the angle who has a tangent that has this for its ratio. So we're going to have to do the second tan of the 240 over 5200. We want that angle back. So if your calculator's in degree mode, you'll get your answer back in degrees. If your calculator is in radian mode, you'll have your answer in radians. So what is the arctangent of 240 over 5200? 3.64 degrees. Make sense? All right. Which is good. You wouldn't want to dive bomb the ground, right? You kind of like to go at a nice little steady descent. All right, so assignment. Same kinds of questions.